In this tutorial, we will solve an exercise on calculating the percentage yield. In previous tutorials, we have explained what is percentage yield. However, let's start with recalling the formula of the percentage yield. So what's the mathematical equation of the percentage yield? That's correct. The percentage yield is equal to the actual mass of a product produced divided by the maximum theoretical mass of the product possible times 100%. So you have to differentiate between two masses of the product. The first one is the actual mass that you have obtained when conducting the experiment, whereas the second mass is called the theoretical mass. So it's the mass that you expect to obtain by the end of the reaction based on the stoichiometry of the balanced equation. Let's solve this exercise. Limestone is made mainly of calcium carbonate, CaCO3. In the production of calcium oxide, CaO, crushed lumps of limestone are heated in a rotating lime kiln. The calcium carbonate will decompose to make calcium oxide, and carbon dioxide gas will be given off. So the decomposition of calcium carbonate will produce calcium oxide, which is the product that we need, and carbon dioxide gas will be given off. A company processes 200 tons of limestone a day, and it collects 98 tons of calcium oxide, which is the useful product. What is the percentage yield of the reaction in the kiln if we assume that limestone contains only calcium carbonate? So we have to find the percentage yield of the reaction in which 200 tons of calcium carbonate will produce 98 tons of calcium oxide. And of course, we are given the relative atomic masses of calcium, carbon, and oxygen. As usual, we will start with writing the balanced equation for this reaction. So this is the decomposition reaction of calcium carbonate. CaCO3 solid will decompose to produce CaO, calcium oxide, which is solid, and CO2 gas, carbon dioxide gas. Let's write down the given that we have. The mass of calcium carbonate is 200 tons, and the mass of calcium oxide produced is 98. So this is the mass of the product obtained. Now we have to find the theoretical mass from the stoichiometry of this balanced equation. To do so, we will calculate the formula masses of calcium carbonate and calcium oxide. We will start with calcium carbonate, CaCO3. The formula mass of calcium carbonate is the relative atomic mass of calcium plus the relative atomic mass of carbon plus 3 times the relative atomic mass of oxygen, because we have 3 oxygen atoms. So it's 40 plus 12 plus 3 times 16, which is equal to 100. Take 1 minute and calculate the relative formula mass of calcium oxide, CaO. Let's check the answer together. The formula mass of calcium oxide is equal to the relative atomic mass of calcium plus the relative atomic mass of oxygen. So it's 40 plus 16, which is equal to 56. So the formula mass of calcium carbonate is 100 and the formula mass of calcium oxide is 56. In other words, 1 mole of calcium carbonate has a weight of 100 and 1 mole of calcium oxide has a weight of 56. And because the stoichiometric ratio is 1:1, this means that if we start with 100 tons of calcium carbonate, we must produce 56 tons of calcium oxide. What if we start with 200 tons of calcium carbonate? How much do we expect to obtain calcium oxide? That's correct. It's 56 times 2, which is equal to 112 tons. So the theoretical mass of calcium oxide that we must obtain if we started with 200 tons of calcium carbonate will be 112 tons. However, we only obtained 98. Here's a hint when solving such exercises. The mass obtained must be always less than or equal the theoretical mass. So now we can calculate the percentage yield. We have the actual mass and the theoretical mass. We will substitute the values, and thus the percentage yield of this decomposition reaction will be 98 divided by 112 times 100, which is equal to 87.5%.